Throughout the entire universe, countless planets orbit distant stars. Most of these worlds are desolate, barren, and devoid of any significant features, but a small number of them hide something extraordinary: an atmosphere. We might take ours for granted, but within this thin layer of gases are the first steps into developing and creating life beyond our own planet. The question now is, can an alien atmosphere support life, and how could we even know? Welcome to the exploration of alien atmospheres. On Earth, our atmosphere does way more than provide the air we breathe. It shields us from the deadly radiation that comes from the sun, regulates our climate through the greenhouse effect, and carries distinct spectral fingerprints. If we could detect these fingerprints on other worlds, it means we have found planets with atmospheres and potentially life. These fingerprints are made of 4 different parts. The first is an element's absorption of light. For example, water mostly absorbs infrared light, but other elements, such as methane, absorb longer wavelength light. Each element has a signature sequence that we can use to detect it like a barcode. Second is the scattering effect that each atmosphere possesses. When there is a large scattering effect, it means that the planet's atmosphere is very dusty, like Venus's. This happens because small particles, like those found in dust, start to redirect the light in all directions, making the scattering effect that we can observe with our telescopes. The third part is the emission lines. When an atmosphere has a lot of one wavelength, it starts to release more photons in this wavelength than in the other. This can let us observe the temperature and the chemical composition of the atmosphere, like if there are lots of infrared wavelength. It may indicate that the planet is very hot. The fourth and final part is to compare it to its star's light. When we try to measure a planet through our telescopes, most of the light that comes from it is actually from its star. To stop this from happening, we have to measure the planet's light when it's in front of the star and when it's behind the star. This allows us to calculate the atmosphere's real light features. By analyzing these cosmic fingerprints, astronomers can determine its chemical composition, cloudiness, temperature, and even tell us if the planet could support life by comparing it to Earth. The next big question we have to answer is, what conditions can support life on these distant worlds, and how do we detect them from across the universe? Currently, our home is the only one that holds life, so we have to use it as a reference point. From our atmospheric data, the Earth is made of 78% nitrogen, 21% oxygen, 0.9% argon, and a small number of other compounds like carbon dioxide or water vapor. The temperature of our planet stays at around 59 degrees. Analyzing Earth's atmosphere provides a template for what we should look for in distant worlds. So far, we've established that researchers can detect the parts of the cosmic fingerprint using advanced telescopes. But what technologies allow these telescopes to detect such detailed information? Well, for advanced telescopes like the James Webb Space Telescope, they use 6 key technologies that enable them to collect this crucial data. First is a spectrograph, which splits the light coming into the telescope into an array for different wavelengths. This device can help us find the emission lines that are needed to determine the types of elements inside an atmosphere by observing how these elements absorb light. Next up are photometers, which measure tiny changes in light when a planet transits its star, meaning the planet goes in front of the star. These technologies help us detect if there is an atmosphere by analyzing if light dims at different wavelengths. Third are infrared detectors, like those used in the JWST. They help us detect the presence of molecules like water, carbon dioxide, and ozone. Fourth is the coronagraph using star shades. These help block out the light coming from the sun and focus on the planet that's hiding in the light. Fifth are adaptive optics, which correct for atmospheric disturbances and increase the detail in images. Finally, these telescopes are equipped with precision radial velocity instruments that measure the star's wobble due to the orbiting planet. These instruments help astronomers measure the planet's mass and size, allowing us to understand its atmosphere even more. Overall, these technologies give us a detailed picture of a planet's atmosphere and maybe even its habitability. Now that we've talked about the technologies that enable us to observe these conditions, what conditions make a planet habitable? Some planets in the universe have a biosignature, a special fingerprint that contains specific chemical patterns that show signs of life. It's kind of like the spectral fingerprints that we were talking about earlier, but only for organic substances. These biosignatures are combinations of gases like oxygen, carbon, and methane, all crucial in the formation of life. For our planet, everything that is organic in some way is made of carbon. Using carbon as a baseline for our research can lead us in the right direction. But finding just one of these gases isn't the only thing that decides if we found life or not. Every single organic element is released or produced by something else, which can lead us to a false view about a planet's environment. For example, methane is released by organisms through waste and other biological processes, but it is also released by volcanoes through their eruptions. What scientists want is not just one of these elements, but a combination of elements that don't coexist without organisms keeping them in balance. Oxygen and methane are very unstable together, but with organisms keeping them in check, both can exist without harm. These patterns are the strongest indicators for life on other worlds, but are also just one step into the grand equation of life. Temperature is another important part of a planet's biosignature. Through the infrared detection that was mentioned previously, we can find the temperature of a planet's atmosphere from the amount of infrared light that comes from it. A temperature around 30 degrees Fahrenheit to 100 degrees Fahrenheit is the optimal condition to support life. So, if we can find a number that is in this range, we can know if this planet is really worth studying or not. Water is also very important. As you probably already know, water is what allows life to survive in the first place. If we find water, which contains certain chemical patterns we have to look for, on other planets along with a good temperature, the planet is worth studying. And all of these factors are determined by the planet's distance from its star. Planets like Earth are in the habitable zone of the solar system. This is why these conditions can form in the first place. A planet too far would be freezing, while a planet too close would burn away the conditions for life. With all this in mind, let's travel the universe to find planets with these unique characteristics. Meet TRAPPIST-1e, a rocky planet in the TRAPPIST-1 system. The planet sits in its star's habitable zone, being showered with its light and heat. The planet was detected back in 2017 by the Spitzer Space Telescope, which uses infrared light. It's around 90% the size of Earth and has 90% of Earth's gravity. For the planet's atmosphere, there is not much known, but we do know that the conditions of its atmosphere suggest signs of carbon dioxide and water vapor. Evidence of carbon dioxide can lead us to hypothesize that the planet has a greenhouse effect that may keep the planet warm enough to sustain water on its chilly surface. But more data is needed to fully confirm this theory. More recent studies have shown that the planet may have an abundance of nitrogen along with methane, very similar to how Earth's atmosphere is. Currently, the JWST and Hubble are trying to find more information about the planet's atmospheric composition, and hopefully we can find much more about this planet. Our next planet is Kepler 452b, a super-Earth that is around 1,800 light-years away from our planet. The planet's equilibrium temperature, which is the temperature that a planet has just from its star, is around 18 degrees Fahrenheit, more than Earth's temperature of 0 degrees Fahrenheit. This suggests that Kepler 452b may contain liquid water along its surface. From what we know so far, its atmosphere could be made of carbon dioxide, which is an important gas to create a greenhouse effect. The planet also has enough gravity to hold all of that gas together, which supports the theory even further. However, without exact data, we can't really determine the extent to which it could support life. The final planet we will review is K2-18b, a sub-Neptune planet more than 2 times the radius of Earth and around 124 light-years away from our planet. The word sub-Neptune just refers to a planet that has a smaller radius than Neptune, so it's not describing a planet that is made of gas like Neptune. The planet's atmosphere, from our knowledge, is made of gases like hydrogen, helium, and water vapor. But what really sets this planet apart is the discovery of a substance called dimethyl sulfide, or DMS for short. This substance is an organic compound that is associated with life and could be found across the atmosphere. The part that makes it unique is that it is mostly produced by living organisms. There are only very few examples of it existing in the wild without the use of biological processes. And to make it even more interesting, this planet is known as a Hycean world, or a world that has a large surface ocean. And we already know that if there's water, there is a small chance that there is life. Like the rest of the planets mentioned, K218b is being studied by JWST and Hubble. So, if we collect more information, we can truly know if this planet contains life. So far, we've explored what to look for in a planet's atmosphere, what technologies to use, and several promising contenders for life. But what's next? Well, we have to answer the question we stated at the start, which is, can alien atmospheres support life? And the answer is maybe, but highly argued upon. The main reason for this answer is that there is not a lot of grounded information about this subject. Without specific atmospheric information from JWST or Spitzer, we can't fully determine if these planets are able to support life or not. But there is hope. Currently, the 3 operational great observatories, which include Hubble's, Spitzer, and Chandra, along with JWST and other telescopes, are trying to discover what these atmospheres are made of through the methods we explored today. In fact, JWST has confirmed the detection of carbon dioxide in the atmosphere of WSP-39b. While it is not a habitable planet by any means, it proves that we are capable of detecting the conditions of other planets. The main issue with detecting conditions on habitable planets is that they are very average, like Earth. Our conditions aren't very extreme, and that is what makes life thrive. The reason we are able to detect conditions on planets like WSP-39b is that its conditions are very extreme and very apparent from our data. But at the end of the day, these discoveries only make our knowledge greater and help us understand our big universe more clearly. And that's basically it. If you like this video, like and subscribe to our channel and hit the bell icon so you can discover more videos like this one. I just want to say thank you so much for watching.